Okay, 1.4, complex numbers. So the imaginary unit I is defined as I equals the square root of -1, where I squared equals -1. So that is a rule we want to make sure we remember. So when we look at complex numbers and imaginary numbers, the set of all numbers in the form a plus bi with real numbers a and b and I, the imaginary unit, is called the set of complex numbers. When we look at the equality of complex numbers, a plus bi equals c plus di if and only if a equals c and b equals d. So operations with complex numbers are going to be the same as what we did with polynomials. So add, combine like terms, subtract, make sure you distribute the negative, multiply, FOIL. The thing is, we need to remember that I squared equals -1 when we simplify, and then we always want to write it in standard form, a plus bi. Okay. So looking at a, we have 5 minus 11i plus 7 plus 4i. So I'm going to rewrite this without the parentheses. And then we're just going to combine like terms. So 5 plus 7 is 12. And -11i plus 4i is -7i. And that's our simplified expression. Looking at b, we have -5 plus I minus the quantity of -11 minus 6i. So we have -5 plus I, and I'm going to go ahead and distribute our negative. So a negative times -11 is a positive 11, and negative times -6i is a positive 6i. Combine like terms. -5 plus 11 is 6, and I plus 6i is 7i. Okay, when we multiply is when things start to change. So 4i times the quantity 3 minus 5i. So 4i times 3 is 12i. And 4i times -5i is a -20i squared. I squared we can rewrite as the quantity of -1. And -20 times -1 is a positive 20. But here's where we have to be careful. This isn't correct because it's not in standard form. So we need to rewrite it 20 plus 12i to be considered correct. Okay. All right, and then looking at D, we have the quantity of 7 minus 3i times the quantity -2 minus 5i. So we're going to FOIL. 7 times -2 is -14. 7 times -5i is a -35i. -3i times -2 is a positive 6i. And -3i times -5i is a positive 15i squared. So I'm going to simplify a couple things. Our -14 is just going to hang out. -35i plus 6i is a -29i. And then this is plus 15 times -1. We can rewrite that, -14 minus 29i minus 15. -14 minus 15 is -29 minus 29i. Check your answer to make sure you're in standard form. We have A plus BI, so we're good. Okay, then we're going to use the idea of a conjugate of a complex number. And so we looked at this a little bit when we were looking at multiplying polynomials. So the complex conjugate of the number a plus bi is a minus bi. The complex conjugate of a minus bi is a plus bi. the multiplication of complex conjugates gives us a real number. So if we do this, we have a times a, which is a squared. A times negative bi gives us negative abi. Bi times a is a positive abi. And then bi times negative bi is a negative b squared I squared. So we can simplify this. Negative abi cancels with positive abi. So we're left with a squared minus b squared. Remember, I squared can be rewritten as a negative 1. B squared times negative 1 gives us a squared plus b squared. So all of our i's went away. So complex conjugates are used to divide complex numbers. The goal of the division procedure is to obtain a real number in the denominator, similar to rationalizing the denominator of radicals. So we're going to divide and express the result in standard form. So 3i divided by 4 plus i. To divide, we're going to actually multiply by the conjugate of the denominator. Here we have 4 plus I, so we're going to change the inside sign to 4 minus I. Then, remember when we have fractions, we multiply straight across. So I'm going to put these in parentheses. So in our numerator, we're going to distribute. So 3i times 4 gives us 12i, and 3i times negative I is negative 3i squared. Then in your denominator, you have two ways you can do this. You can either FOIL, which is what we're going to do on this one, or you can use that shortcut a squared plus b squared. So 4 times 4 is 16. 4 times negative I is negative 4i. I times 4 is a positive 4i. And I times negative 1 is a negative I squared. We can simplify. So we have 12i minus 3 times negative 1 over 16. Negative 4i plus 4i cancels, minus negative 1. Okay. So 12i plus 3 over 16 minus negative 1 is 17. So here's the thing we have to be careful. We still need to write it in standard form, a plus bi. So we're going to break this apart to be 12i over 17 plus 3 over 17. And then we're going to swap them. So 3 over 17 plus 12 over 17 with the I on the end. And that is your simplified expression in standard form. So now if we look at B, 7 plus 4i divided by 2 minus 5i, we're going to multiply the top and the bottom by the conjugate of the denominator. Here, the conjugate of the denominator, 2 minus 5i, is going to be 2 plus 5i. What we multiply on the bottom, we also multiply on the top. And then I'm going to go through and put parentheses around everything so we can FOIL. So looking at our numerator, 7 times 2 is 14. 7 times 5i is 35i. 4i times 2 is a positive 8i. And 4i times 5i is a positive 20i squared. Okay, I'm going to use the shortcut for our denominator. Remember, our shortcut was, let me move this up a little bit. A plus bi times a minus bi. So we're going to do a squared plus b squared. So here, a equals 2 and b equals 5. Okay. So we're going to have 2 squared plus 5 squared. So zooming this back in, I'm going to rewrite this kind of shorthand. So 20i squared is the same thing as 20 times negative 1, which is negative 20. So we have 14 minus 20. Then we have 35i plus 8i, so plus 43i, all over 2 squared is 4, plus 5 squared is 25. 14 minus 20 is negative 6, plus 43i, over 4 plus 25 is 29, and then break it apart. So we have negative 6 over 29 plus 43 over 29i. One thing to be careful about is that you check these fractions to make sure they can't simplify or reduce further. Okay, the last part we're going to look at with complex numbers is simplifying by taking the principal square root. So we can rewrite any negative square root or radical. The square root of negative b equals I times the square root of b. So if we look at a, the square root of negative 18 minus the square root of negative 8, we can break this apart. So remember, we always want to look for our perfect squares. So I'm going to rewrite the square root of negative 18 as the square root of negative 1. And 18 can be broken up to the square root of 9 times the square root of 2. The square root of 9 is 3. The square root of negative 1 is I, and then we're left with our square root of 2. Minus, okay, the square root of negative 8. This is the square root of negative 1. And then 8 can be broken up to the square root of 4 and the square root of 2. The square root of 4 is 2. The square root of negative 1 is I, and we're left with the square root of 2. So now we have like terms. So 3i minus 2i is 1i, and then our square root of 2 just kind of hangs out. It's like our variable, it's like the x. So that is our simplified form. Okay, looking at b, we have negative 1 plus the square root of negative 5 squared. So when we square something, it's the same thing as writing it twice, but when we rewrite this, I'm going to put the I in front of the radical and get rid of that negative. And then we can FOIL. So negative 1 times negative 1 is a positive 1. Negative 1 times I square root of 5 is negative I square root of 5. I square root of 5 times negative 1 is negative I square root of 5. And then I square root of 5 times I square root of 5 would give us I squared times the square root of 25. So we have 1. Negative I square root of 5 minus I square root of 5 gives us negative 2I square root of 5. Plus I squared is negative 1, and the square root of 25 is 5. Negative 1 times 5 is negative 5. So it's 1 minus 2I square root of 5 minus 5. Then combine like terms. 1 minus 5 equals negative 4. And then we have minus, and I'm going to kind of change this, 2 square root of 5. And then I'm going to move that I on the end. So that way it's in our a plus bi form. Okay, and then last one, negative 25 plus the square root of negative 50, all divided by 15. So we can reduce this. If we look at the square root of negative 50, this is the square root of negative 1 times the square root. So 50 can divide it by 25 and 2. Because 25 is a perfect square. So this gives us I times 5 times the square root of 2. So if we plug that back in, we have negative 25 plus 5 square root of 2 times I, all divided by 15. And then if we want to write this in standard form, we're going to break it apart. So we have negative 25 over 15 plus 5 square root of 2 over 15i. But this is where we need to make sure we reduce our fractions. Negative 25 over 15, those numbers are both divisible by 5. So we have negative 5/3 plus 5 over 15 is again divisible by 5. So the square root of 2 over 3i. And there's your simplified form.